welcome to my YouTube channel. Today we are going to solve this problem, that is construct binary tree from preorder and inorder traversal. So in this problem we have given two integer arrays, preorder and inorder. Okay, and where preorder is the preorder traversal of a binary tree and inorder is the inorder traversal of the same tree, and we have to construct and return the binary tree. Okay. So here first let's copy this input and output. Okay, so here this is our preorder and this is our inorder. And what is preorder? So in preorder, first we access mid element, after that we go to left, and after that we go to right. And in inorder, first we get left, after that we get mid, and after that we get right. Okay, so here from this it is clear that first element in the preorder is our mid, that is the root of the binary tree. So first element in the preorder is always mid, which means that this tree is the root. Okay, so now let's write code for this. So first in this tree node build tree function, let's call one more function. Okay, so let's return this function, return build tree help, and in this function pass preorder array, inorder array, and after that pass pre-start. Okay, so what is pre-start here? We are going to access first element, so that is pre-start is 0 here. After that we are going to access this inorder elements, so first element, so in start is 0. So here pre-start, in start and in end, which I am going to write now, they are nothing but indexes. Okay, so indexes of these elements. So this is pre-start, 0 means this 3, in start 0 means first element of this, and in the end we are going to write in end. So in end, for in end we are going to write in order dot length minus 1, that is 4, fourth index. Okay, so fourth index means this 7. Okay, so now let's define this method here. Write public tree node build tree help, and in that pass one preorder array int preorder, after that pass inorder array, after that we are going to pass indexes, so just define them as int pre-start, after that we are passing in start, after that we are passing in end. Okay, so these three different indexes, and after that now in this we are going to check basically two conditions here. But two conditions, first we are going to check if pre-start is greater than preorder dot length. Okay, and this condition, that is in start is greater than in end. Okay, so in this case we are just going to return null. So in this method we are checking these two conditions in the if statement. First is if pre-start is greater than, it should be greater than equal to preorder dot length. So this is our preorder, and preorder dot length is 5, and we don't want to access elements after this 7, that is index number 4. Okay, so if our index at any point of time is 5, then this condition will be true. Okay, so that is why is greater than equal to, and same way in start greater than in end. So in start we are starting from 0 and in end index is 4. So when our index is 5, that is this in start is 5, at that time also this condition will become true. So if either of these two statements become true, okay, or same or single one, then in that case we are just going to return null. Okay, so why these two conditions we are using? So that we don't get any index out of bound type error in the arrays. Okay, so that is why we are going to use these two. And after that we are going to define the new root for this tree node. So for this tree node, root is equal to new tree node, and in tree node first element that we are passing is this 3. And how we get this element 3? So we get this element from the preorder and preorder's first index, that is 0. Okay, so inside that write preorder and which element? First one, that is this pre-start. Okay, so write pre-start here. So first we are going to access this element. Okay, so after that now we access this first element, and we know that first element of the preorder is root. Now we are going to find the index of this 3 in the inorder. Okay, so for that purpose we are going to write, just create one variable int type int index as in start it from 0, from this 0, and now we are going to search for this 3 in this inorder. So for that write one while loop, while in index is less than equal to in end. Okay, so we are going to search all the elements, and in the while loop check if element in this in order. So in order, which element? We are going to start from index, in index. So if this equals to root dot value, okay, so from here we get the root value from the pre node, okay, from this preorder. Okay, it should be preorder. Now if this condition is satisfied, then we are going to just break this loop, and if this condition is not satisfied, so in the else part we are just going to increment the in index. Okay, so now after that we are going to get the size of the left subtree. Okay, so now let's say in preorder this is the first element 3, and we find the 3 here in the in order. So now we are going to get the size of the left subtree. So what is the size of left subtree here? Okay, so it should be 1. So how we get this left subtree size? So for that we are going to create one variable int left subtree size is equal to, how we are going to get this size? So this is the our in index where we get this 3 value. So here I am going to write in index, and I am going to minus it with this first. And what is this first element? That is nothing but in start. So in this way we are going to get the size of left subtree. Okay, so this is the size of left subtree. So this is how I get the size of left subtree in this in order array. Okay, so now I get this left subtree size. Now after that I get this root element. Now I want to insert root.left values. Okay, so in root.left we have only this 9. Why? What is in order? So in order is left, mid, right. So we get these 3. So all the elements in the left are the root.left, and here these are the elements are root.right. Okay, so now for root.left I'm going to write like this: root.left is equal to, I'm going to call the function build tree help, and in this function I am going to pass same preorder, I am going to pass same in order, and now what I am going to pass here in this value in pre-start. Okay, so first we access this value 3. Okay, so now I want to go to this value, next value. Okay, so for this next value, how I can go? I am going to next value by just adding +1 to this pre-start. Okay, so this is how I am going to go to the next value. So see what is happening here. First I get this root. Okay, so now I want to take this as a root. Okay, I am going to take the next element in the preorder as root. So how I am going to take that? By just incrementing the value of this pre-start. So here pre-start becomes pre-start +1. Okay, so for this pre-start +1, now for this I am going to get the instart. So instart will be same here. Again we are going to start from 0 only for the left values, instart, and now in index. So now I'm going to get the values till here only, okay, and our in index is this one, this 3, and I want to take the values till here only for the left subtree. So for the left subtree this will become my in end position. Okay, so for in end position I am going to write nothing but in index -1. Okay, so I hope that you guys are able to understand this. Okay, so I am going to search this element. I pass this pre-start +1, and I want to take the root.left values. So this was the root, and now I want to take these values. So I am going to start from here only, and from one step before this root, this index, from this index. So this is our in, and this is our in start as well. Okay, so in this way I am going to get the root.left values by again calling the recursion. And now for right values I am again call this function build tree help. Okay, so now again I am going to pass this same preorder in order. Okay, so now here what is going to be our pre-start? Okay, so for pre-start I am going to write pre-start plus left sub tree size +1. Okay, so this is going to be our pre-start, that is the next value, that is this 20. So I am going to get this 20 by using this pre-start plus left subtree size +1. Okay, so now see why I am doing like this, since we need to get only the right values. Okay, since we need to get only right values, so for that purpose we need to add our left subtree's value as well, so that we don't want to include our left subtree's values. So that is why we are going to write like this. And now this time our in index becomes, now we are going to search the values from this 15 to 7. So this was our in index, so I am going to search the values from here. So our in index becomes, so here our in start, so our in start becomes nothing but in index +1, and we are going to go until end this time. Okay, so we are going to get all these elements. Okay, and here why we are using this? Because we want to skip the left subtree values. Okay, so that is why we are going to insert this left subtree size. Okay, so now after that, that's all that we need to write, and in the end just return root. Return root. Now let me try to run this code and see if there is any errors. Okay, so here in this function we need to include this. Okay, okay, so there are some mistakes. Let me try to fix this code. Length minus 1, and in this function we are checking if pre-start is greater than equal to pre-order dot length, or in start is greater than in end, and we are returning none. Okay, and here in index we are taking it in start, and while in index is less than in end, if we are checking this value is equal to root dot value, and we are breaking, otherwise we are incrementing this size, and after that we are going to get this as in index minus in start, and in the root dot left we are passing this pre-order in order pre-start plus 1 in start, and then in index minus 1. Oh here, oh shit, here I need to write root dot right, not root dot left. Okay, so let me run it again. So now our solution is accepted. Let me try to submit our code. Okay, so all the test cases have passed. Okay, so here once again on the top I will cover everything. So first we are going to get this first element pre-order, this 3 we pass it here. After that we are going here root dot left, we get this is 9, and after that we go to this left, we get null, we go back. After that we check the right of this 9, so we get null, so we go back. After that we are going to get this 20, and for this 20 we are going to check 15 first, and then after that we are going to check this 7. So in this way, so here one more thing, after this 20 we are going to get this 15, and for this 15 again we are going to check left and right. In the if left is null, then we go back, and then after that we are going to check this right of 15. If this is null, then after that we are going back, and after that we are going to check 20 is right, and when we get this value, after that again we are going to check it's null. So there is no null, so that's in this way this code will be executed. So I hope that you guys are able to understand this code. Please like, share and subscribe my YouTube channel. Till then, keep coding and keep practicing. Thanks.